Hello, this is Ryan McQuan, and this is my video presentation for assignment 2. Let me run my program. Let's play with 3 flies, and let's enter the column. My strategy is going to be trying to block and consolidate my territory. You see here we block out the AI. He's intelligent enough to go diagonally right here, so he plays over here. So the AI will continue to make moves that are optimal. So in this case, while I built up, the AI made sure to build right here to optimize his diagonal and his left and upward points. And that's what he did. I simulated the game board as a subclass of my game class. My board I made as a character 2D array. The scoring of the board would basically go through and recursively check the points of that piece played. So if a piece was played, it would check all the 8 squares around it, add up the points, and then return that. That's my game class. My main loop would be start game right over here. While the board is not in a finished state, the player would go, which is a fairly straightforward loop. That would only allow him to play moves in playable columns. So if I would say play move and play 10, if I was to play a move in column 10 or 15 or 0, it would re-ask the user for an input. After that, the AI would then make a move. And this is going to be the main minimax loop. So the first iteration would check for the direct children of the given game state or the given game board. And then for each of the children, the program runs a minimax, the minimax algorithm on that board. It would make a list of children, and then if the given board node is of type is a max, it would then make new game boards that were min moves. Vice versa, if the given board was a max, it would then add children that were of a max type. Since as you go down the tree, every layer will alternate from min to max to min to max. And so then at the end of each of these, it would then run the minimax again. Essentially what we're doing is a depth first until the number of plies has been reached. Once the number of plies has been reached, we will then find the maximum. If it's a max node, we would find the max of that list. So I can use the collections.max operator on the children array list using the node comparator, which I created, which basically compares 2 nodes given their scores. I would find the maximum node, which would be the move, which would maximize the score for the max player. Vice versa, if it's a min node, we would then find the minimum of those children and then set that min node with the score of the minimum child. Those values would percolate up to these base children. And then since this is the AI making a move, we would then find the maximum of that children list. Thank you, and that's the end of my presentation.